Okay, so we're going to just continue what we've already done. The difference, though, is that before when you looked at the other polynomials, let me move this, there was just a 1 in front of there. So now we're going to expand on this. So they want to know what's different is you have the 6. But we want to list all the possible factors. This is my rational root theorem. This is my PQ method. Keep that in mind when you have a quiz question where I say name all the possible roots. Okay. So I'm going to look here. This represents my P. This represents my Q. All right. So let's start with the P. Plus or minus 1 divide, plus or minus 2, plus or minus 3, plus or minus 6. Well, what do you notice about all the Q? Well, that's still plus or minus 1, plus or minus 2. I'm just going to write it so that you can see. And that represents my P, that represents my Q. Well, I actually don't need to count these, but you also have options not only of P, not only of Q, but P over Q. So that means 1 divided by 1. Well, that's the same thing. 1 divided by 2, 1/2. So plus or minus 1/2 is a possibility. Plus or minus 1/3. Plus or minus 1/6. All possibilities. Let me zoom that out a little bit, and then I come over to the 2. 2 over 1 is 2, done. 2 over 2 is 1, done. 2/3, so plus or minus 2/3. 2/6 is 1/3, so you don't need to put that. Now let's go to the 3. 3 over 1 is 3, done. 3 over 2, not done. 3 over 3 is 1, done. 3 over 6 is 1/2, done. Now let's go over to the 6. 6 over 1, 6. 6 over 2, 3. 6 over 3, 2. 6 over 6, 1. So when I ask, list all the possible answers that could work. Now some of you go, what are you talking about? Let me remind you. Let's say I wanted to find out where it crosses the x-axis. I don't have access to a cell phone. I need to show my work. And I don't want to guess every number in the whole wide world because I want to limit it. This tells me those are all the possible whole numbers and fractions that could work. Now you could get decimals, you can get imaginaries, but these are the only possible whole numbers and fractions that could work. So that means 4, not even an option. All right. Now I have a choice. I can do reverse box. I can do synthetic division. I can do synthetic substitution, but what I don't like about that is by doing synthetic substitution, I'm not narrowing it down and getting smaller and smaller and smaller. So I don't really like that way. And then long division, literally in the name, it says it takes a long time. My favorite is synthetic division, but if you like reverse box, that's great. I just make more mistakes in reverse box. So I'm going to start with positive 1. So I go 1, 6, 7, negative 36, negative 7, 6. Okay? And I'm going to pause it, and we're going to decide if it works or not. So I tried 1. It's going to have a remainder, so 1's out. So now what I'm going to do is I'm going to erase that. And I'm going to try negative 1, the advantage of a pencil. Okay, so I'll pause it. I have a remainder. Negative 1 doesn't work. So now I'm going to try 2. Pause it. So 2 actually worked because the remainder was 0. So one of my factors is 2. I started with 4. I have 1. Now I have 3 left. 6x cubed plus 19x squared plus 2x minus 3. Now, here's the deal. You go, okay, well, I tried all the 1s. Those didn't work. I tried the 2. I didn't try negative 2 yet. But I want to look. This is my new p. Well, if this is my new p, that means that 2 doesn't work because 2 doesn't divide 3. So I don't even need to try negative 2. That also, but does it mean that 6 could work? Yeah, because 6 divides 6. Okay? So when we're doing these types of problems, we want to narrow it down. If you don't know what I'm saying, then don't worry about it. You're just going to try it and it's not going to work. Okay? So I'm going to try 3 now. And so I'm going to go, let me do that in pen. 6, 19, 2, negative 3. Let me erase the p because that can be confusing. Okay, I'm going to pause it and we'll see if it works. So I didn't even finish because what's 3 times 37? Really big number. And if I add it to 2, I'm not going to get negative 3. So, I mean, yeah, I'm not going to get 0. So now I'm going to try negative 3. Let me pause it. Okay, I got 0, so negative 3 works. So now, I have 2 of them, but I need a total of 4, so I have 2 left. So 6x squared plus x minus 1 equals 0. I have an option. I can keep trying this. But I honestly don't want to do that because I'm really good at factoring. So let's factor it and get the answer. So I magic X'd it, and some of you go, wait a minute, I wish you would have shown me how to do it. That means you need to be asking me for questions about how to factor. Okay, at this point, you cannot be struggling. So let me just do a quick one. For those of you that know it, great. This times this gives you this. Two numbers that multiply to get that and that are 3 and negative 2. But you have to remember, you have to take that leading coefficient, divide it out, simplify, and solve. If you see here, I got how many solutions? I got 4. How would I describe these solutions? I could describe them as 4 real solutions. A fraction's are really a number, okay? So I got 4 real solutions. Now they want you to do a rough sketch. So I've got 2, negative 3, negative 1/2, and 1/3, not done to scale. It's okay. Okay? If it's to the 4th power, it's even, positive, it's going to look something like this. I like drawing that. There's no bounces, so everything goes through. I know I didn't spell through right, but you get it. Because there's no repeats, there's no bounce. Next thing I need to figure out is the y-intercept. So how do I get the y-intercept? Plug in 0. 0, 0, 0, 0, 0. The y-intercept is 0, 6. So now I'll start graphing. Rough sketch. If you're copying it at this point, you need to be brave enough to practice. Some of you can do this because you're cute little robots, but this is the part you struggle with. So this is the part I need you to be brave with. Okay, that's how we get better at things. All right. Oh, I didn't actually do this. Put it in factored form. P of x equals. If I have 2, that's x minus 2. If I have negative 3, that's x plus 3. This one, it's nice because I don't have to go backwards. It's right there. I don't have to go backwards. It's right there, so it's less thinking. How do you know I'm right? Take this, put it in decimals. Take this, put it in decimals. They should be right on top of each other if you did it correctly. Okay? Keep in mind, roots, x-intercept, zeros, they all mean the same thing. All right. So give me a second. I'm going to read this one. So what they're saying is Carlo had this polynomial. He divided and he got one of the factors. So he knows that one of the factors is 3. So let me zoom in on this and look. Here's the graph representation. And if you look, oh, here it is at 3. So then it said he tried all the other ones, but he couldn't get them. Because if you look, that crosses at a decimal and that crosses at a decimal, so he couldn't do it. And people were thinking, oh my gosh, or Carlo was thinking, how am I supposed to get the other 2 answers? This looks like grouping, but if I tried to factor this by grouping, there wouldn't be a match. So how the heck am I supposed to get the other ones? Well, hopefully you noticed that this bounced. So that if this bounced, that means not only does x minus 3 work 1 time, but it works 2 times. So what they want you to do is now go x cubed minus x squared minus 7x plus 3 divided by x minus 3. So I'm going to do synthetic because I like it better. You can do reverse box. I don't care. Okay, figure out the answer. So I had 3 x's. I took out 1. That means I'm left with 1x squared plus 2x minus 1 equals 0. And now I can't find 2 numbers that multiply to get negative 1 and add to 2. So that means I'm going to have to do the quadratic formula, which is something I knew because that was a decimal and that's a decimal. So I know that it wouldn't be factorable. Okay. Now, by the way, you go, well, does that mean all decimals are not factorable? No, because negative 1/2 is a decimal, but I can quantify that, negative 0.5. Okay. All right. So I'm going to solve by completing the square. Let me pause it. You can solve by the quadratic formula. Find the answer. Go. So not only did I solve it, I checked it. So what I did is I went into decimals here, and that's 0.41 and negative 241, and that looks pretty good to me. Okay, so we got the roots. We have 3 with a bounce, and then so x equals 3 with a bounce. But technically it's x equals 3, okay? But we know the bounce means there's actually 2 of them, and then x equals that. There's a total of 4. X to the 4th power, we're good. Okay? Now we're on the homework. This is a shorter week, so let's make sure we're solid on it so we get full credit. Sketch the graph, identify the zeros. You can do that. Make sure you're doing the right type of factoring. To me, these look like hint, sum of cubes and difference of cubes, which means you'll have one real answer and two complex, or two imaginaries. All right, so they want here, they gave you the complex zeros, and they want the equation in standard form. This one, they want you to use, just plug in p sub 2, and then determine one of the factors. You know how to do that. That's what we just did. And then they want you to finish solving it. It looks like it got continued. This is a good one. Hint, hint, nudge, nudge. So they want to know what would give it or have real solutions. So a real solution means that it really crosses the x-axis. Okay, you have an option of 2 reals. You have an option of 1 real. And you have an option of 0 reals, which is 2 complex. Okay, so you want to, you know, try some numbers, or even think about the quadratic formula, because it's all based on what's in here. If this ends up being a positive number, it's 2 reals. If this ends up being 0, it ends up being 1 real. And if you have the square root of a negative number, that's imaginary, and that's complex. Okay? Let's see, estimate the minimum score. You can read that and figure it out. This one, use homework help if needed. This one, simplify logs. Okay? So you really only have 2 homework assignments for the week. So please, ladies and gentlemen, make it happen.